This is Unit 3, Lesson 4, Part 1. The topic is graphing quadratic equations from tables. Okay, so we're going to be learning a little bit of an introduction to these quadratic equations and then how to graph them using our first method, which will be tables. So kind of like we did absolute value, we're going to start off with a table, and then once that makes sense and we understand how the function works, then we'll start to introduce kind of some shortcuts in a later lesson. So quadratic function, standard form looks like this. So we could have what we call a quadratic term, a linear term, and a constant term. This is the only term that's always there. You might not have this, you might not have this. That's what the standard form looks like. So it creates what we call a parabola. You guys have seen that before in Algebra 1 for sure, that kind of U-shaped curve, which is different from the V shape of the absolute value. It's not pointy on the bottom, it's rounded on the bottom. So we're gonna look first at just a sketch of these graphs so you can get an idea of what the equations turn into when you graph them. So I'm going to pull these open on Desmos. Okay, so this first one. I have x squared plus 2x minus 5. So to take a look at this, kind of move it around a little bit. So we are looking for literally just a sketch, just kind of an imitation of what that looks like. And if you want to at least know that bottom point right there, so you've got -1, -6, and then it looks like it crosses through the y-axis at -5. So just to give you a little bit of an idea. So it looks something like that. And I literally just mean a sketch. So that was the first one. Let me clear that out. And I'll enter in the second one. So the second one is -x squared plus 3x plus 7. So get that. Goes a little bit higher. This is the general shapes. The main thing that we're looking at is, yes, it's still that same parabolic U-shaped curve, but this one is upside down. That's the big difference between these two. So it goes up, comes back down. The sketch looks something like this. So the conclusion that we're drawing down here is if A is positive, so remember A is this thing in front of the x squared, there's technically a +1 here. The parabola will open up like this one does. If A is negative, so you've got this -1 in front of the x squared, then the parabola will open down. So that's a big idea that we're going to use throughout the next couple of lessons, and that will be really important to helping you know what the shape is supposed to look like. So some different parts, some different vocab words that we'll talk about here. There's a vertical line that divides the parabola into 2 equal parts. That is called the axis of symmetry. So it kind of like runs right down the middle here. And if I was better at graphing that symmetrically, it should be perfectly symmetrical on both halves of that line. This one I did a little bit better. So there's a vertical line, runs right down the middle, that it should be perfectly symmetric on opposite sides of that line. So you can see it a little bit better with this one. The axis of symmetry. You actually have a formula to find the axis of symmetry for each one of these. And it is this. It's x equals, because it's a vertical line. So vertical lines are always x equals. And it's -b over 2a. So b is whatever's in front of this x right here. Keep in mind it could potentially be 0. And the a comes from this right here in front of the x squared. So that formula we're going to be using, starting in the examples down below. We have a turning point, just like we do with absolute value. It's called the vertex, just like it is with absolute value. So you've got this turning point right here where the graph is going down, it turns around and goes back up. Or a turning point right here where the graph is going up, it turns around and goes back down. So that point is either the minimum point or the maximum point of the graph. So let's add a couple things on here. So this is right here. This is the minimum point of the graph because it's the vertex, but it's the lowest point. It's going down, it turns around, and it goes back up. Whereas this right here we consider to be the maximum point of the graph. It is the vertex, but it's the highest point on the graph. There is no lowest point because these arrows keep going down. So label those parts on the graph above. That is what we are looking at right there. We can also label this the axis of symmetry. And again over here. Okay, so just a couple labels to add on to your picture there. So now we're going to look at some examples on the bottom half of this page. The directions say that we first want to determine whether each function has a minimum or a maximum. Then we're going to try out those formulas, try out the axis of symmetry and the vertex. So let's look at number 3 first. So here's what you look at to answer this first question. Minimum or maximum is going to depend on what the value of a is. So a is a -2. So first of all, that puts me in this category. A is negative. So my parabola opens down, which means it looks something like this. And if it looks something like this, then my vertex would be a maximum. So you can kind of follow what this tells you up here. So it's going to be a maximum, and that's because my graph is upside down, which means that it has a high point rather than a low point based on this value right here. So axis of symmetry, let's follow this formula. So x is equal to -b/2a. So negative b is whatever is attached to the x, and there is no x. So in this example, b is actually 0. And then over 2a, a is a -2. That's this value right here. So 0 divided by anything is just 0. So that's the axis of symmetry. It's an x equals line. So it's going to be a vertical line that's actually just right on the y-axis, x equals 0. And in the vertex, one thing I want you to notice is the vertex is an ordered pair rather than a line, but it's always right on the axis of symmetry, which means the x-coordinate is the same x-coordinate as the axis of symmetry has. So I know for a fact that my vertex is going to be 0, something. Not because it's always 0, but because this one happens to be 0. So then what I do with that is I take that 0 and I plug it into my equation. So my vertex is what I get when I plug 0 into this equation. So -2 times 0 squared and then plus 7. So this whole thing is just going to end up being 0, and then plus 7 means I get 7. So my vertex would be 0, 7. That on the next page is going to be the first step to how we plot these functions. All right, so let's also look at number 4. Number 4, if we look at a, that's always our starting point to answer this question. We look at a, which is technically a +1. So if a is positive, the parabola opens up, it looks more like this. And if it takes on this shape, then our vertex would be a minimum. Next, use the same formula for the axis of symmetry. So the formula that we have right up here. So -b, b is a -8. So this is like a -8 over 2 times a. So 2 times, technically a 1 from in front of the x squared. So I have 8 divided by 2, which is 4. So that's what I write down for my axis of symmetry. It's an x equals line. And then I know for a fact that my vertex lies on the axis of symmetry. So the x-coordinate is going to be 4, and then I just have to find the y-coordinate. Same thing I did with number 3. I'm going to take 4 and plug it into this equation right here. So I want to plug in 4, so that'll be 4 squared minus 8 times 4 plus 9. So 4 squared is 16, minus 32 is -16, and then plus 9 comes out to be a -7. So that is the y-coordinate, that is my vertex. So that's the first type of question that you guys could be asked in this section. On the next page, we're going to look at actually graphing using tables and how that comes out. So on the next page, we're going to do the evens. So starting with number 6. So you have step by step that I can walk you guys through. So step number 1, find the axis of symmetry, just like we practiced on the previous page. So I have x equals -b, so -6 over 2 times a, which is 1, so 2 times 1. That gives me 3. So I have the 3, and just like I did with the, sorry about that line, just like I did with absolute value, we want to put that in the middle row. So the vertex will come. I don't really have to worry about finding this right this moment. Once I plug the 3 in, I'll get the vertex. So I use 3 as the middle row on my table, and then I number up and down, and then I can complete my table. So the way that this is going to work, because I have symmetry, I really only have to fill in half of my table, okay? Because I know that the other side has symmetry, so let me talk you through exactly what that means. So I plug in 0. 0 gets plugged in for x. I am going to kind of just say this out loud because mental math is a strong suit for me. If it's a strong suit for you, great. If you need to plug things into your calculator, great. But we are just subbing this in as the x value. So 0. 0 squared minus 6 times 0 plus 11 ends up just being 11. Then I can plug in 1. 1 squared minus 6 times 1 plus 11. So that's 1 minus 6 plus 11. And that ends up giving you 6. Again, plug it into a calculator if you need to. If you plug in 2, you get 4 minus 12 plus 11. That is 3. And then this point ends up being the vertex. So when I plug in 3, I get 9 minus 18 plus 11, which is 2. Now, here's what I was saying with the symmetry. The symmetry means my graph turns around and it goes back up and it hits the exact same points that it hits on the way up. So if this is 2 and this was 3, the symmetry tells me that this is also going to be 3. And then this is also going to be 6, and this is also going to be 11. So that symmetry means you've got this like perfect mirror image on both sides of the vertex. So using that, let's plot these points. 0, 11 is going to be, I think, probably too far off the grid. Yeah, this only goes to 8, so let's just ignore the 11. 1, 6, you'll still see enough of the shape. So 1, 2, 4, 6. 2, 3 is right here. Then here comes the vertex, 3, 2, over 3 up 2. That's the vertex, that's my turning point. So my graph is going to turn around once it gets here and be a perfect mirror image on the other side. So you can see that, and then the 11 is too high. So there's our curved shape of the parabola that I can connect here. Make sure you've got your arrows on both sides. And then once you're looking at the graph, looking at the table, we can do our domain and range. So fun fact, just like absolute value, the domain is always all reals because the domain is what x coordinates can you plug in, and you can plug in anything you want into a graph like this. The range is what comes out of that graph, and that's the y values. So always look at the vertex. This y coordinate is 2, and that is the very lowest point on the graph. So you could say y could be anything greater than or equal to 2 because it starts at 2 and then it just goes up from there. So that's one example. Let's look at another one that has a negative in front of our x squared. Let's look at number 8. So find the vertex first. That's step number 1, or I guess axis of symmetry. So we do x equals negative b, and there is no b. So we have 0 over 2a, which would be 2 times negative 1. So of course with 0 in the numerator, that just ends up being 0, which I can put right in the middle of my table here, just like I did with number 6. And then I number up and number down. And then remember, you really only have to plug in half of the table. You can plug in the bottom half of the table or the top half. I'm going to show you, like in my opinion, I'd rather plug in positive values than negative values. So I'm going to start from the bottom up and the results will still be the same. So I'm going to plug in this 3. 3 squared is 9, and then I do have to make it negative. Follow order of operations. Make sure you square first and then make it negative. So this does come out as a negative 9. And then plus 5 would be negative 4. So I can use my symmetry and say that this would also be negative 4. Okay, next is the 2. 2 squared is 4, make it negative. So negative 4 plus 5 is 1. So this would also be 1. Then I plug in the 1. 1 squared is 1, make it negative. So negative 1 plus 5 is 4, which means so is this. And last point, my vertex right in the middle. Plug in 0, so it's just 0 plus 5, and that is my vertex. You can see it's going to be the highest point out of all these y values, which makes sense because this is negative, so it's flipped upside down, and that makes your point a maximum. So plot these 7 points. So we have negative 3, negative 4, so 1, 2, 3, down to negative 4. Negative 2, 1 is right up here. Negative 1, 4 goes even higher. And then my vertex is going to be right on the y-axis, 0, 5. So then, after that, I just do this perfect mirror image on the way down. So that is what my graph looks like. I'm going to connect the dots, and then I can do domain and range. So that's the graph. Domain is always all reals for every type of quadratic. Range is based on where the vertex is. This is my highest y value, which is a 5, but then my graph goes down from there. So underneath the 5 would be y is less than or equal to 5. Okay, so a couple examples of just one graph. We're going to finish off by looking at a piecewise graph. So for number 10, the top line right here is just a line because nothing's squared, it's just mx plus b. So I'm going to graph this part first. Remember, piecewise are always done in pencil. So plus 5 is my y-intercept, started off right there, and my slope is 2. So I can go up 2 to the right one. I can also go down 2 to the left one. Do that a few times. So connect the dots. This is my line. And I'm doing it in pencil because I need to see what part I'm keeping. So this, I want to keep everything less than a -4. So let's just double check my accuracy here. So go down 2 to the left, down 2. Okay, so that's a little bit better. So less than -4. I have -1, 2, 3, 4, and that goes to this point right here on the graph. So that's where my graph is going to begin. And I want just less than, which means open circle, and I want to go to the left of -4. So I'm going to keep this portion to the left. Remember, up or down doesn't matter. It's all about left and right. So I'm going to erase what's to the right of that point, keep what's to the left, and it's also got to be an open circle. So open circle, and then let me be a little bit more careful with going down to there. That's a little more accurate. Probably should have been more accurate as I was plotting it the first time. So that's our line segment. This is really a ray, I guess. Then I can do this part, which I will do by making a table. So I can set up my vertex. So I have x equals -b is -3 over 2a. So this is -1.5. So that's a little bit unusual, but we will set that up anyway. So -1.5. And then from there, I would just go to the next whole numbers. So if you go up, that would be -1, and then 0, and +1. And this would go down to -2, -3, -4. So I would do it that way. Just stick with whole numbers for everything else. So let's plug in half the points, and I think it'll be easier to start here. I'd rather plug in 1 than -4, but I know I can still use the symmetry. So if I plug in 1, I have 1 plus 3, which is 4. So this is also 4. And I plug in the 0, which is super easy, because that would just be 0 plus 0. And then -1, this comes out as a +1, and this comes out as a -3. So that would be a -2. So with this, and that one you might want to plug into a calculator, plugging in a decimal. So this, plugging in the decimal, I'm going to do that just in my phone calculator real quick. So when I square -1.5, I get 2.25, and then plus 3 times -1.5. So that comes out as -2.25. So just a tiny little bit below these points. So let's plot those, make sure we're doing it in pencil. So -4, 4. 1, 2, 3, 4, up to 4 right here. Then -3, 0 should be right on the x-axis. -2, -2 is down here. This one, we got a bunch of decimals, -1.5, and then this is like barely below, -2.25. Remember, that's the vertex, and then I have this perfect mirror image on both sides right here. So connect the dots, that's what our parabola looks like. You can see our vertex. And this says I want to keep everything with an x value to the right of -4. So I know this point has an x value of -4. So I'm going to erase the part to the left, keep the part to the right, and I get to keep this closed circle because this is greater than or equal to. So keep the closed circle and just cover up in pen this part right here. So you've got a big chunk of a parabola and then a little line. So domain, all the x values get covered because I include everything between both of those lists. And the range is what x values get covered. So this one you look for, remember, maxes, mins, jumps. So there's no max, there's no min, but there actually is this little gap right here. This one stops when it gets to a y coordinate of -3, and then this one doesn't pick up again until -2.25. So everything -3 and below, so I would write less than -3, just a less than because this is open. And then the little union symbol in this part starts again at 2.25 and goes up. So there is actually the tiniest little gap between those two y values.